Hello everyone and welcome back to Space Engineers. This is the first video that I'm going to be doing as part of a new series which I'm calling SE or Space Engineers Academy. And I decided to start doing this largely because after joining Discord and word getting around that I've got about 3,500 hours into this game, some people have been asking me some pretty basic questions about some pretty basic concepts, which is understandable considering that many of them have less than a week into playing this game, so there's a lot of stuff that they don't know. And I was in much the same place when I first started playing this game. I remember having to rely on a lot of my friends for getting a lot of advice on how to build stuff. Well, yeah, a lot of stuff that I made just, well, kind of bombed. In fact, my first capital ship that I ever built was actually pretty cringeworthy. I mean, the thing was ugly and blocky, had no weapons, and could barely even get off the ground, much less out of the planet's atmosphere. But anyway, the first lesson that I want to touch on is basic propulsion systems. Now, this is nothing super fancy, no thrusters on rotors to create VTOL thrusters that convert into forward thrusters. No, this is just simply placing a thruster block and making it make your vehicle or your ship go. So there are basically four kinds of propulsion systems. There's ion drives, which work in space only. And by space, I mean where there's a complete and utter lack of atmosphere. So basically, going to my normal view, they work out there. They will work on the moon because, again, no atmosphere. They will have reduced functionality in the Mars planet atmosphere because even though it's not oxygenated, it is a very thin atmosphere. So ion drives might work, but they will have reduced power output. I think it's like at whatever would be the equivalent of sea level, the thrusters have like half their strength available. Don't quote me on that. On the Earth-like planet, at sea level, they have 30% strength. They start to gain more and more power as you get above the 3,000 meter mark, because at that point the air starts to thin, and as the air gets thinner and thinner, the thrusters get more and more powerful, and eventually reaching maximum performance once you are fully out of the atmosphere. Which is to say that you are high enough that down there at the bottom where those two green words are, where it says O2 high and warm, when it says O2 none and temperature shows cold, at that point the thrusters, regardless of gravity, will have their full strength. Of course, how fast you're able to ascend away from the planet will also be mitigated by planetary gravity. So basically that would mean that your ascension would be slower on the alien planet compared to Earth-like or Mars, which the alien planet's gravity is 1.2 Gs, whereas Earth is 1 and Mars is 0.9 and the moon is 0.25. Now, atmospheric drives only work in a planetary atmosphere and only up to 3,000 meters above ground level. The reason for that is because they require full atmospheric density in order to function. Now, they will function on the Mars planet and the alien planet because they are dependent on air density, not oxygen content. So they will work on Mars where there is no oxygen, but just as with how ion thrusters have, in terms of planets with atmosphere where they work, ions have the most power on Mars at sea level compared to Earth or the alien planet, which both have dense atmospheres. Mars is thin. So while ion thrusters have more power on Mars than they do the other two planets, atmospheric drives are the weakest on Mars compared to the other two planets because of the thin atmosphere, and they will not work on the moon at all, at least not the Earth-like moon, or the Mars moons because those moons are also airless. As far as I know, they do work with full Earth-like planet intensity on the moon of the alien planet just because its atmosphere is the same as the Earth planet. Then, let's see. Next we have hydrogen engines, which those work at full power everywhere. But unlike ion and atmospheric drives, which, these two run on electricity, hydrogen runs on hydrogen fuel, and very, very minorly do they run on electricity. The electrical part is basically the hydrogen flow regulators that or at least it would be represented as, hydrogen regulator valves that are controlled by the computer on your ship that opens the valves to let more hydrogen into the thruster cone to generate thrust. And then finally, you have wheels and suspensions, which only work where there is gravity and where there is enough to keep your vehicle from launching itself into the depths of space because you decided to go all Evel Knievel on that one hill on the moon, and you somehow overcame the moon's gravity and launched yourself into deep space. Now, those are pretty self-explanatory. The suspension is basically a electric drive motor that you attach to your vehicle, and then the wheel is, well, that's pretty self-explanatory. So basically, that's for building rovers. Which, for those of you who are really very, very brand new, and you're just now learning the game, and you decided to start off in a star system and start off on a planet, that's probably going to be your first build, is a rover. Rovers are fairly easy and simple. Rovers can range in size from small car all the way up to being something as massive as a 10-story building. It just depends on what you're hauling. And they can even be constructed to be as massive as mobile bases. But for the most part, I'm not going to be touching on rovers. I might do those on a later video. The next topic for basic propulsion is fuel and power management. Now, to kind of put this into context, I'm going to take you over to one of the most complex ships that I have ever built. Transporter room is this way. I'm going to use the transporter because that's faster than flying out of a door and trying to fly to the ship, and yeah, you get the idea. Now, this would be the type of ship that you would build We're beaming over to that gray ship over there. But anyway, the type of propulsion system that I built into this ship, which is a hybrid of ion and hydrogen, is built in for two reasons. One, because hydrogen can be used literally anywhere, but it has the caveat of it burns hydrogen gas, and so as a result, because of the fact that it burns through it rather quickly, you have a limited fuel supply. Which actually, we're going to go to engineering. There we go. Where's my gas meter? There we are. This ship carries 20 million liters, that's what the ML stands for there, of hydrogen gas. In trying to escape planetary gravity, this ship will probably burn through that fairly quickly if I'm, not trying to escape the planet's atmosphere, but if I'm flying around using this ship as if it were an airplane without throwing on some atmospheric jet engines, this thing will burn through it rather quickly. Though, after having tested this on trying to get from ground level to space, it only uses up maybe 20% of its fuel. And that's if I hammer the engines the whole way. There is ice on board to kind of replenish the supply a little bit, but, it's not going to be enough to fully refuel this ship, I don't think. And then the ion thrusters run off of this power core and these here batteries. Now, the reason why, aside from being able to make this ship able to land on planets and operate in space in the most efficient ways possible, the reason why for the hybrid propulsion system that runs on both hydrogen and electricity is so that way I have more versatility. I mean, if in the event that, these batteries are running low and this warp core is running low on uranium, I could always turn the electrically driven ion thrusters off and then use the hydrogen propulsion system. But when I'm operating in a planetary atmosphere, my hydrogen engines are the only thing that are going to keep this ship from crashing into the ground. Where am I going? Oh yeah, I'm on deck 3. Okay. Now, there are some craft that I have built that run entirely on ions just because they are not meant to operate in an atmosphere at all. And I'm going to show you one of those now. Well, actually, before I do that, I'm going to show you guys what these thrusters look like. Now, these here are armored ion thrusters. These come from a mod. Basically, what these thrusters would look like in vanilla is you strip away this armor plating and you basically have what's inside of it. And it's the same thing with this hydrogen one here. I mainly use the armored ones aside from the extra hull integrity. It also minimizes disruptions to the lines of the ship's profile. So these here would be ions. That one there would be a hydrogen. It's offline right now. So these bad boys are here to operate as a reaction control thruster, and at the same time, because of the fact that they face forward, let me show you a better angle. That's the front of the ship right there. They run parallel to the axis that runs front to back. So yeah, those are reverse thrusters. Those ones there push the ship down, and then those ones push the ship up. And then of course I got thrusters for left and right. And that's another thing too, is when you are placing thrusters on a craft that is meant to operate in space, regardless of where else you might intend it to operate, you're going to want thrusters in all 6 directions. Up, down, left, right, forward, and reverse. The reason being is because you shouldn't have to turn your ship 180 degrees to get it to stop. You know, unless the build you came up with somehow makes it to where you have more thrusters in back than you do in the front, but there's actually a way to counter that. That more than makes up for it. In fact, as far as the ions go, you can only see half of the thrusters the ship has from the outside. The rest of them are inside of these nacelle housings. If you look into the gaps between these spotlights, you can kind of see them. Yeah, it's like those blue glowing things in there. The reason why I have those in there, believe it or not, is you see these thrusters can only generate so much force. Now, that being said, if you look, like let's say you get directly in front of this ship. If the thrusters are only where you can see them, then by appearances, there are 3 thrusters there, 2 there, and then 3 there. That would contribute to slowing the ship down or stopping it, along with those 3, if the ship was flying along at full blast. It might take several kilometers to stop this ship, and it might take, 2 or 3 minutes, using just those 8 thrusters. But using an engineering trick, there is a way to increase that amount. Basically, you can create the effect of having in the same point along the ship's silhouette several thrusters doing the work instead of just one. Because after all, in this game there is no rule that says your thrusters have to face into space in order to work. And even if there was, remove the window covering that creates a smooth surface here, and these thrusters in there would be exposed to vacuum, and in fact they still are, because there's no vent in there pressurizing anything to weaken those thrusters. Now, the flame from these thrusters, because they will damage things, goes out 2 blocks from the emitter point on a small thruster. So for instance, the flame on this thruster right here would come out to about here, give or take, and it would damage anything along its path. Now you could have another, now you back up a little bit to where you're in the safe area. You could have another thruster right here facing the thruster we are looking at now. Those two thrusters can shoot flame at each other and they won't damage each other. And that's basically what I've done in these nacelle housings, which I'll show you. Let's see here, and let's delete all those. These here are basically thruster nacelle banks. I have here 3 thrusters that are set in a row here to provide reverse thrust. Behind them, 3 more providing forward thrust. As you can see, this is kind of a repeating theme. Oh yeah, that's right, the flame goes back 3, well, actually, I think it goes 2, but I always add a 3rd block just in case. Because if the flame, you know, licks out of like even just another meter or so for like 1 frame, it'll damage the thruster that's at the other end of it, of this deal here. So by having this kind of a setup, it gives yourself more acceleration power and more stopping ability. And if you make your engine nacelles bigger and wider, you can even add other directions to it. So there you go. And I've done that in all 4 nacelles. So while this ship, given that it's only got, let's see, 2, 4, even though it's only got 6 ion thrusters providing left and right movement, and then ignoring those big hydrogens, which I use to keep the ship in the air when it's in an atmosphere, there's 2, 4, 6, 8, 9, 10, 11. Okay, so 22 small ions for upward thrust, and then 2, 4, 6, 7, 8, 9, and then, okay, so 18 providing downward thrust. You know, okay, so yeah, this ship tends to be a little sluggish with lateral and vertical movement, but when it comes to taking off and stopping, this thing can almost stop on a dime when it's not loaded. Now that's another thing about designing your propulsion system. The heavier your ship, the longer it's going to take for it to speed up, slow down, maneuver, stop drifting, you know, anything along those lines. Let me just seal this back up here. Whoops. Okay, yeah, there we go. Now, this ship has, aside from the decorative components which add weight, the ship also carries 12 large cargo containers, and when those things are full of ore, this ship goes from being able to start and stop on a dime to being able to start and stop on a skyscraper that is laying on its side. The reason for that is because the equation that the game uses to determine how fast you can accelerate and slow down is based on the weight of your ship, the weight of the cargo it's carrying, and your thruster output. So think of this whole convoluted mathematical mess as something referred to as a thrust to weight ratio. The better that ratio is, the faster you can start and stop. The more that ratio, on the other hand, favors the mass that is being propelled, then the more sluggish your ship is going to become. And if you're building a vessel like this that is going to be operating in an atmosphere, that can be a bad thing if it's running entirely on atmospheric thrusters, because if you overweigh the craft too much, you can actually overcome the thrust provided by your lifting engines, and your ship will just fall straight to the ground, or your aircraft, or whatever it is. Which brings me to these. These are also modded thrusters. These are, I forget who the modder is. I think it's Intech. Yeah, it's Intech. Now, These are called tiered thrusters. These are tier 4. Now, the way that mod works is that tier 1 is worth 2 vanillas, tier 2 is worth 2 tier 1s, and so on and so forth. So, going from vanilla to tier 4, it's 2, 4, 8, 16. Okay, so this thruster has the same output as 16 large block, large hydrogen thrusters. Of course, some of that thrust is reduced, or some of the effective thrust is reduced by the fact that this thing is heavily armored. Again, it's so that I can have an airtight seal, so that atmosphere is not venting through where the armor is, because the vanilla thrusters don't have the armor plating. And secondly, it also reinforces the thruster in the event that the thruster itself is hit by weapons fire or some other kind of object. But anyway, these thrusters provide thrust specifically for keeping the ship off the ground when it's flying around in the planetary atmosphere, so long as there is hydrogen fuel to power these engines. Which again is why in space, if you have a hybrid propulsion system, you'll want to use your ions as much as possible and save your hydrogen fuel for if you have to make planetfall and you would prefer to be able to salvage your ship. Now, you also may have noticed that I have hydrogen thrusters in all 6 directions except for 1. I don't have any hydrogen thrust going that way for one simple reason. Because it's supposed to facilitate atmospheric flight, I don't need hydrogen thrusters in a position to be able to push the ship down when I need to land. Because all I need to do to make this ship land is pulsate turning those thrusters off and on. Whenever I pulse them into being off, planetary gravity takes over and the ship will start to descend. And then when I need to slow down how quickly I'm descending, I turn them back on and the speed dampeners do the rest. They take over slowing the ship, and I just switch between having them stop the ship and having them not stop the ship, and I can facilitate landing that way. But in space where there is no gravity whatsoever, if you need to make the ship fly down in the orientation it's facing, then you'll want thrusters facing up. So, there you go. Now, when it comes to like the main thing you got to figure out when you're doing any kind of a thruster setup is you need to try to figure out how many thrusters you need, what directions you need them facing in, and also how much thrust you need in each direction. Now, for a vessel that is operating in an atmosphere exclusively, you don't need downward thrust, again, like I said, because gravity can help you with that. Which brings me to fuel and power management. In a hydrogen-powered system, the best way to manage your fuel, turn your dampeners off. So that way when you let go of W or whatever button you're using to move in whatever direction you're wanting, you turn dampeners off and you will coast continuously in that direction until you either turn dampeners back on or the game spawns an asteroid in your path and you slam into it at 100 meters per second. With ions, the issue is not so much fuel.
Low.
Yes, I know. The issue is not so much fuel. It's making sure that, well, depending on how big your ship is, you might have to worry about fuel because if you don't have enough battery power, you're going to have to use uranium to propel your ship, and if that starts to run low, then you're in trouble. The Gagarin over there in that hangar, over in that shipyard, doesn't have that issue. It's got enough batteries to run the thrusters at least at a quarter strength, while the hydrogen thrusters are not operational, or if the core is offline. With the hydrogen engines, again, it's just gonna if hydrogen is all I've got, I'm not going to be trying to land on a planet unless it's the new one they added, Triton, because that planet's almost pure ice, which is what you get hydrogen gas from. Now, as far as making sure you have enough thrust, this one is tricky, especially with aircraft. Because this game does not use aerodynamic wings to help with lift. Now, there is a mod for that, but that's not actually using the atmosphere to generate lift. What that is it is an atmospheric thruster that has no thrust, but ridiculous dampening power. Which dampening is the setting on a thruster that allows it to stop your movement in a given direction. Think of it like this. Most thrusters that use the vanilla settings, they have a 1-to-1 ratio on force used to speed up and force used to stop you. If a modded thruster has, say, a 10-to-1 ratio on dampening to thrust, what that means is that, say you have two of those thrusters, and they're facing, they're like this, you got your forward thruster and your reverse thrust. This thruster will have enough power to make you accelerate like this, but then when you hit the reverse thruster, it'll stop you way faster than the other one sped you up. But what if you tried to stop by holding down S, which is the opposite of W? W is forward, S is reverse. You'll find that on a thruster that has a 10-to-1 dampening to thrust ratio, if you just let go of W, you'll stop on a dime. But if you try to hold S, well, now you go from trying to dampen your forward momentum to you're now trying to thrust in reverse, and you'll find that you're having a very hard time slowing down. The wing mod is basically that. It is it's like a thruster that has no thrust, but its dampening is so ridiculous that it makes your downward momentum almost zero, which allows you to glide. Notice I put that in quotes because you're not gliding on air, you're gliding on magical thrust, but it accomplishes the same goal. Now, as far as making sure you have enough thrust, what I found is the best formula to use, and this applies to vanilla thrusters. Remember, if you're going to use the tiered mod, your thrust going from one tier to the next is doubled. So compared to a vanilla thruster, tier 1 is twice as strong, tier 2 is 4, tier 3 is 8, tier 4 is 16. Now, the first thing to consider when you're counting in vanilla thrusters, for every large cargo container, you want one large atmospheric thruster. So if you have 10 large cargo pods that are going to be full of ore or something very heavy, you'll want to have 10 large atmospheric engines pushing down. That would be the same as 5 tier 1s or 3 tier 2s. And in the case where the math says that there would be a remainder, you would add a whole nother engine for that. So that would be 10 vanillas, 5 tier 1s, 2.5 tier 2s or 3 tier 2s, 2 tier 3s, or a tier 4 plus an extra 6 containers. And the weight of those containers being full will cancel out the thrust from the engine, and the thing just will not move. So if it was already in the air, that engine's going to be able to hold it in place, but it's not going to be able to lift it up any higher. But it will stop it from falling down. Then, depending on how much more your craft weighs, you'll want to add more hydrogen power, or not hydrogen, more atmospheric power, which, let me show you here. By the way, the engines of all the different atmospheric tiers look identical. What is not identical is the way they perform. Okay. So like this here would be an atmospheric engine. Of course, we're in space, so it has no power. Or, well, it'll use power, but it won't provide any thrust. So basically, this thing here is worth 2 vanillas. So, depending on how big your craft is, if it's just big enough to encompass, say, 10 large containers and not much else, then you'll be good with the ratio of 10 engines for 10 containers plus an extra 1 or 2 facing down. For acceleration, slowing down, and maneuvering, that one you have a lot more leeway with. Just know that if, once you got your hovering problem solved, if you're not able to accelerate quickly, the solution is simple. Add more thrusters. But remember, the best way to do your engines, because for the most part they do have a 1-to-1 ratio on thrust versus dampening power, you'll want to have as many thrusters for going in reverse as you do going forward. That way, however fast you're able to get up to top speed, you'll know that you'll know that when it comes to slowing down, however long it took you to speed up in the first place, it's going to take you the same amount of time roughly to come to a stop, and that'll make it easier to take into account when that mountain is coming up really, really fast and you really would much rather not hit it. Now, as far as like just having just enough thrust to overcome your craft's weight, it might be a good idea to go overboard on that number, just because of the fact that if that mountain is coming up way too fast and there's no way you're going to be able to avoid hitting it in the first place, if you have enough excess hovering thrust, you can always just bound right over the mountain, provided it doesn't go over that 3-kilometer limit. Excuse me, it's like really late here. So that's all I got for atmospheric thrust. Hydrogen is better in terms of raw power than atmospheric for flying in an atmosphere, just because one hydrogen engine has 120% the power output of the same size and grade of the atmospheric jet engine, plus the hydrogen thruster's lighter, believe it or not. But there is the extra weight of having to have a hydrogen tank, if not more than one. So, with regards to making sure you have enough thrust, just remember these simple rules. First, if you're operating in gravity, you need to have at minimum just enough thrust to where when your vessel is loaded, you can still get off the ground. What I use as a rule of thumb is look at how much power your thrusters draw when you're sitting in the cockpit seat, which I'll get up here to one just so I can show you. Excuse me. And I'm sorry my game's lagging a little bit, but that's just because I'm recording. So, you should now see over here on my bottom right, I've now got another HUD element. Now, where it says 0, let me just move this over where I get some contrast here. Where you see that 0, that means that right now my entire station is using less than 1% of the total output capacity of its power grid. Which, if I had thrusters on this, and I don't, because it's in space, it doesn't need them. If, hypothetically, if I was in an atmosphere, and my thrusters, my lifting thrusters at full power output, pushed my power grid to 50% on their own, with no other directional thrust being involved. Okay, so just the thrusters that are pushing down. If at full blast they draw 50%, then at idle with a full load of cargo, I would not want my power consumption to exceed 35%. The reason why is because out of between 35 and 50%, that is another 15% of power that, when utilized, will push the craft up where 35% is enough to hold it in place. Adding that extra 15% will allow it to ascend. Though the further from whatever is the most that those thrusters would draw, the further away from how much it draws at an idle, the better. You can do that by either reducing the weight of your craft or by adding more thrusters. Adding more thrusters is usually the more popular solution. Now, with hydrogen thrusters, this is a bit more tricky, because their power draw is about the same as a light bulb. Because the only thing that is drawing electricity in those engines, or at least that type of engine, is essentially the flow valve that the vessel opens and closes or adjusts to maintain certain thrust levels when you're pushing the button, or if you're flying in gravity and you're telling it to maintain your altitude. The power output or the power draw on your electrical grid is always going to be the same. But generally what I try to go for is however many atmospheric thrusters you would need, you're going to need about the same amount in hydrogen, plus maybe a few extra ones to account for the fact that now, instead of having extra batteries, you're going to have to stock up on hydrogen tanks, and you're going to have to fill those tanks. But hydrogen thrusters make up for this, well, I guess you can call it balancing of a sort by, well, let's see, how do they make up for it? Oh yeah, any given thruster of a particular grade will have more power output than an atmospheric or ion thruster of the same grade. So Tier 4 ion and atmospheric thrusters put out the same amount of thrust in their respective environments where they have 100% efficiency. Atmospheric in an atmosphere, ion in space. A hydrogen thruster puts out the same plus 20% more in both environments. But again, you have to carry hydrogen tanks and fuel, and the means to make more fuel. So the fact that you're having to carry tanks and ice and H2O2 generators is countered by the fact that they provide 20% more thrust, and that's to make it for the added mass. So generally speaking, however many thrusters you would need to be able to get a certain amount of performance using atmospheric or hydrogen, or atmospheric or ion, you're going to need the same amount of thrusters of the same type and grade in hydrogen. And then, yeah. Now, there is a simpler way to do this math. There is a script on the workshop called Can It Fly? I am not entirely certain if it's been updated since the last time it broke, but the last time I checked it was version 4, and basically what it did is it looked at the mass of your vessel, the thruster output of its engines, the cargo capacity of its containers, and then it would tell you whether or not it would get off the ground. If it said no, it would tell you why. If it does, it'll give you a general idea of how good your engines are going to perform. Now, other than that, another script that works too, this is a chunk of a script by a modder called MMaster on Discord and the Steam Workshop, but basically it's an automatic LCD script. Now, there is commands that are not in use on this station because, well, it's a station, it does not move. But basically there are commands in the online guide for that script that basically tell you that, you know, if you do this and this, and if you punch in this information, it'll print to one of these LCDs like these. How long it's going to take you to hit top speed, how long it's going to take you to stop, and, you know, just general information that will help you to determine whether or not your vehicle is going to even get off the ground before you even set foot in the cockpit and start mashing the space bar. So those are definitely two scripts to look into. As far as I know, Can It Fly is still broken, but there might be a new version of that out now. It's been over a year since I last checked. So anyway, that about covers it for basic propulsion systems. Maybe back here next time where I will talk about not just propulsion but also maneuvering, which is turning your ship and and turning a vehicle and things like that, and applications for putting flight maneuvering systems on a rover style vehicle. I don't know if I'll have a working rover by then, but well, technically I suppose you could take my shuttle and put wheels on it and that makes it a rover. So there you go. And I will see you guys next time. This has been Space Engineer Academy. I am, of course, the Sage of Games, coming back for what I guess would be Season 1 of the reboot, or Season 2 of what I had going on before. I don't know. Let me know in the comments below which you would prefer. Also, if there's any basic concepts that you would like me to make a video about, hopefully, and just leave me a comment. Let me know what basic concept you would like help with, and specifically what aspect of it you need help with, and I will try to make a video geared specifically to that topic. So that not only will it help you, but it'll also help out anyone else who has that same question down the line, because there will be someone who will. After all, nobody starts this game knowing what to do. I know I didn't. I know I didn't get my first properly built capital ship until I was about around the 500 hour mark. But that's just because I like to take my time learning things. So, I will see you guys next time. And see you guys out there. Bye-bye.